Okay, in this session we'll see the operations that we can perform on the graphs. The operations that you perform on the graphs are similar to those of the sets. Okay, the operations on the graph can be union, intersection, product, addition, subtraction, difference. Okay, and we have got fusion boliye ya merge boliye. Okay, all these are the operations that we are going to perform on the graphs. Okay, let's see with the first one, that is union of graph. Union of graph is similar to that of the union in the sets. Union में हम क्या करते हैं, we have got two different sets, right? We are going to add those two sets. Add क्या? We are going to club those two sets, right? Same thing here. अगर आपके पास एक graph है G and you have got a graph H, two graphs G and H, so you are going to add all the vertices and edges that are present in both. ठीक है, we are going to club both the graphs. ठीक है, अगर इसका definition में हम बोले, this is a graph, we have got a graph G, which has got what, यहाँ पे VG हम इसलिए लिख रहे हैं, it is a vertex of G, it is a vertex of E, sorry, it is an edge of G. Same way, it is a vertex of H and it is an edge of H. ठीक है, we know any graph contains vertices and edges. So vertices and edges of G and vertices and edges of H. इसका अगर हम यूनियन बोलेंगे तो vertices भी add हो जाएंगे, vertices will be added with the vertices and edges will be added with the edges. Suppose this is a graph given 1 and this is a graph given 2. So the edges, let's see the vertices first. A, B, C, D, B, E, D. So A, B, C, D, B, E, D. Done. The edges now E1, E2, E3, E4, E4, E5, E6. So E1, E2, E3, E4, E5, E6. Done. Simple, right? Just same as the sets. Same thing for intersection. Intersection में हम क्या करते हैं? We are going to take the common out, right? दो graphs given है आपके पास, उनमें से common edges and vertices you are going to take. ठीक है? वही vertices and edges which are common in both of them. Just same as sets. Okay. Suppose same thing आपके पास एक graph given है which has got vertices and edges and H same vertices and edges. तो इसका intersection क्या होगा? If this is a graph given to you, this is G and this is H. Now the intersection graph will look like this. अब कैसे? You have got vertices 1, 2, 3, 4, 5, 6 and the edges are here. E1 से लेके E10 तक you have got the edges. This is G. This is another graph H. This is not a subgraph of this. This is some other graph only. ठीक है? तो यहाँ पे आपके पास एक graph है जिसमें you have got vertices 6, 2, 3, 13, 4, 5 and 12. The edges are 7, 8, 9, 10, 13 and 12. So if you see here, यहाँ पे vertices which are common are 5, 6, 2, 3 and 4. 5, 6, 2, 3 and 4 are common. This 12 is not present in this one. This 13 is not present in this one. So this 2 will be removed. The rest are same in both the edges, both the graphs. So we are going to combine them and write it. तो ये आपका हो गया G intersection H. ये दोनों graphs का intersection जिसमें आपके पास ये यही vertices है 5, 6, 2, 3, 4. That's it. Okay, 2, 3, 4, 5, 6. That's it. And edges which are associated. Edges को भी देखना है. Suppose अगर आपके पास यहाँ पे E11 होता, यहाँ पर E10 है, यहाँ पर E11 है. Both are different. You're not going to include this. Getting? The edges must also match. This is intersection. Clear? Let's see the other ones. Okay, moving on, we have got graph join या sum of two graphs, कुछ भी बोले आप उसको. यहाँ पे see, you have got one graph and you have got another graph, G and H. G contains 3 vertices and H contains 2 vertices. Now, the addition, yeah, the sum or the join of two graphs means what? You need to connect each vertex with the other vertex. ठीक है, you are going to add all of them. मतलब एक vertex दूसरे एक graph के vertex से are connected to all the vertices of another graph. Getting? This way. A is connected to, you have got ABC here and DE here. So ABC, DE, done. So A is connected to D and E. B is connected to D and E. C is connected to D and E. Also, इन लोगों के बीच में already link था, so that will be as it is. Here if you notice, जो नया ग्राफ आपके पास फॉर्म होगा G plus H will have new pair of vertices. Edges. New pair of edges. Vertices तो same है ABC, DE. ABC, DE. But the edges that are formed are new. ठीक है, थोड़े पुराने हैं, that is A to B, B to C is as it is, D to E as it is, but these are formed new. ठीक है, some pair of edges will be new pair of edges will be formed. Okay, now this is done. Now difference of the graph. Difference मतलब क्या, we know this, जो आपके पास common नहीं है, we are going to write them. Okay, difference मतलब which are not common in both, that we are going to write. Suppose this is one graph G and this is one graph H. So G minus H is this. Suppose this is your graph given and this is your another graph. If you see here, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5 are common in both of them. So we are not going to take those. Matlab 1, 2, 3, 4, 5 we are not going to take them. The rest which are present, 8, 6, 7, 8, 9 and 10 are present. So this 6, 7, 8, 9, 10 we are going to take them. Okay? Clear? All the vertices will be there but the edges will be subtracted. The edges which are not there in both the vertices, that we are going to include. Clear? Okay, let's continue with the next operation, that is ring sum. Ring sum is denoted with a plus sign and then a circle this way. Suppose we have got two graphs G1 and G2. Then G1 ring sum G2 will be something like this. See, in a graph we know that we have got vertices and edges, right? If we want to find the ring sum, then we are going to find the ring sum of the vertices G1 and G2, then ring sum of the edges of G1 and G2. Okay, both the things. Okay, when we are finding the ring sum of the vertices, what happens? It will give you V of G1 union V of G2. Matlab you are going to club, or you are going to add all the, not add, I can say you are going to club union of the vertices. मतलब क्या, all the vertices will be present in the final graph. Clear? Next, edges में what's going to happen when we are going to perform ring sum of the two graphs for the edges? What happens? E of G1 union E of G2. Okay, here E of G1 intersection E of G2. Union मतलब what? All the edges will be present. Intersection मतलब क्या? Only the edges that are common will be present. ठीक है, इन दोनों का difference we are going to take. That means what? We are going to include only those edges that are either present in G1 or present in G2. We are not going to include the edges which are present in both. Clear? I'll repeat it again. We are going to include the edges that are only present in either G1 or in G2. We are not going to include the edges which are present in both the graphs. Okay. Whereas for the vertices, all the vertices will be present. Okay. Now let's draw a final graph. Suppose these are the graphs. This is suppose G1 and this is suppose G2. The first thing that we need to do is we need to club all the vertices. All the vertices should be present. Okay. Let's write down the vertices. Here we have got 1, 2, 3 and 4 for the first graph, 4 vertices, and here 1, 2, 3 and 5. Okay, so total how many? 1, 2, 3 are same, and 4 and 5 vertices. Okay, you can draw it in any manner, it's up to you. 1, 2, 3, 4, 5. Okay, vertices are done. Now comes the part of edges. Now we need to see the edges that are present in either G1 or in G2. It should not be present in both. Okay, let's start one by one. Let's see the first edge. 1 to 2. We have got an edge that is X. Let's check here. 1 to 2. We have got an edge that is X here. Right? So that means we are not going to include it. It is same in both the cases. So we are not going to include this edge. Done. Next edge. 1 to 3. There is an edge Y here. Let's check. 1 to 3. There is an edge Y here. So we are not going to include this edge as well. Clear? Next, 2 to 3, we have got Z here. Let's check. 2 to 3, we have got C here. See, this is a different edge. This is a different edge. Although it is between the same vertices, but the edges are different. Okay, यहाँ पे it is Z and यहाँ पे it is C. The values are different. Okay, so we need to include these both edges. This should be included. This should be included. Okay, so it is 2 to 3, right? 2 to 3. There will be an edge that is Z. Okay, from 2 to 3, there is one more edge that is C. 2 to 3, one more edge that is C. Done. Now, let's see the next edge that is 3 to 4. 3 to 4 we have got an edge y. Do we have any 3 to 4 here? There is no vertex 4, so no question of the same edge or not. Okay, so 3 to 4 we have got an edge, that is y, w. 3 to 4 we have got an edge, that is w. We are going to include this because that is not common in both of them. Okay, next is this graph is completed now. Let's move on to this graph. 5 to 3 we have got an edge, that is b here. Okay, 5 to 3 we have got an edge, that is b. 1 to 5 we have got an edge, that is a. This is completed. 1 to 5 I have got an edge, that is 5. There is no 1 to 5 here, so no question of same or different. 1 to 5, 1 to 5 a. Clear? All the edges are done, completed, all the vertices are done. So this is your final graph, G1 ring sum of G2. Very simple, only you need to keep in mind that you are going to include only those edges which are either in G1 or in G2 but not in both. Whereas for the vertices, the vertex set will be as it is, the combination of both. Clear? Now let's moving on to the next one, that is finding the product. See, obviously here any graph will have vertices and edges. A product में क्या हो जाएगा? You are going to multiply. What you are going to multiply we'll see individually for the vertex set and for the edge set. A vertex set में what happens? Vertex of G1 and G2. We are going to multiply the vertices of G1 and G2. You are going to get the union of it. That means all the vertices should be present in the resultant graph. Okay? All the vertices should be there. Done. Next, let's come for the edges. Edges ka when you are going to multiply the G1 and G2 ke edges, what happens here? V of G1 into E of G2. Matlab G1, G2, vertices, edges, vertices, edges. Okay, so you are going to multiply the vertices of G1 with the edges of G2. Going to multiply vertices of G1 with the edges of G2. Okay, these two is going to be multiplied. Then vertices of G2 will be multiplied with the edges of G1. Matlab ulta. Vertices of G2 will be multiplied with the edges of G1. Cross multiplication will take place. After multiplying, cross multiplying, we are going to club all these, union. ऐसा नहीं है कि उनका difference लेना है या उनमें से common लेना है. No, we are going to include all these. इनको multiply करने के बाद जो भी मिला वो, and इनको multiply करने के बाद जो भी मिला वो, we are going to club and write it. Clear? Now, let's go with the edges first. Let's draw a graph. Suppose this is my G1 and this is my G2. Now I need to find the product of these two. How am I going to find it? First, we are going to multiply the vertices. V of G1 into V of G2. First, these two needs to take place. V of G1 into V of G2. So now here, V of G1. Vertices of G1 we have got as, यहाँ पे दो vertices क्या है? A and B. For here we have got 0, 1 and 2. 0, 1 and 2. Now we are going to multiply them. A will be multiplied with 0. A will be multiplied with 1. A will be multiplied with 2. Same case, B will be multiplied with 0, with 1 and with 2. ठीक है? सारे के सारों को आप you are going to multiply them. So the resultant will be here. V of G1 into G2 will be A into 0, A into 0, A into 1, A into 2. Done? Now, B into 0, B into 1, B into 2. B into 0, B into 1, B into 2. Clear with the vertices? Now, let's go with the edges now. Edges में what you need to do? Vertex of G1 into edge of G2. ठीक है? यहाँ पे vertex of G1 है, यहाँ पे edge of G2 है. That means you are going to multiply A with E. One thing. Next, A with F. Second. Done. Then B with E. B with F. Same thing. AE, AF, BE, BF. Done. Next, the second vertex set of the second graph into the edge set of the first graph. Opposite. So this will 0 will be multiplied with U, then 1 will be multiplied with U, and 2 will be multiplied with U. First come the vertices, then comes the edges. Okay. So 0 into U, 1 into U, 2 into U. Clear? Now let's construct a graph. These two are done. Okay. Let's see the vertices first. A0, A1, A2, B1, B0, B1, B2. Let's construct this. Let's plot these points. A0, A1, A2. Right. B0. You can plot it in any fashion. I'm going to go in this manner. There is no restriction की ये यही आना है, ये यही आना है. This vertex can be anywhere. You can draw it, construct it anywhere, you can construct it in any manner. Okay. The vertices are done now. This part is done. Now let's include the edges one by one. Okay. Here if you see, we have got A, comma E. A क्या है यहाँ पे आपके पास vertex है, E क्या है edge. Okay. Let's see the edge. Where this edge is present, E. The edge E is present between 0 and 1. ठीक है. Let's check for 0 and 1. 0 and 1. Okay. This E will be included. A comma E will be included. Getting? Now here, this is your vertex, this is your edge. F जो edge है आपका वो कहाँ पर present है? F is present between 1 and 2. Let's check for 1 and 2 here. 1 and 2. Even here we have got 1 and 2, but we are searching for A. यहाँ पर A है आपके पास. तो A of 1 and 2. So here what you will get? The edge set A comma F. Getting how we are doing this? Now B comma E. The E is the edge here. E कहाँ है अब देखिए आप? E यहाँ पर है. It is between 0 and 1. 0 and 1. 0 and 1 of what? B. So 0 and 1 of B में you will be having what? B comma E. Clear? Same way F. F is between 1 and 2. It is for the vertex B. So the vertex यहाँ पे है आपका B. 1 and 2 क्या है? यहाँ पर है. Okay. So here you will be having B comma F. Okay. Clear? Next. 0 comma U. U is the edge. U is the edge. It is present between A and B. A and B. So you are going to draw here 0 comma U. Okay. Now comes 1 comma U. U is again a vertex here. It is between A and B. So you are going to draw it in here. 1 comma U. Getting? Next. The last will be 2 comma U. Obviously U is between A and B. 2 comma U. ठीक है, we have got a 2 here, इसलिए 2 comma U. We have got a 1 here, इसलिए यहाँ पर we are going to have 1 comma U. Although it is between A, B, A, B, A, B, but you have got 2 here, 1 here and 0 here. So accordingly 0 comma U, 1 comma U and 2 comma U. Clear? So this is how your final graph is going to look like. This is your G1 cross G2 or G1 product of G2. Okay, so in the product what you are going to do, you are going to multiply all the vertices and you are going to multiply vertex set of one graph with the edge set of the other one, and you are going to combine them. Okay, remember these formulas here as well. In the ring sum, all the vertices will be there. There is no new pair of vertices. All the vertices will be there. For the edges, you are going to include only those which are present in either G1 or in G2, not in both. Okay, let's move on with the further operations. Okay, the next is complement. Complement of a graph means what? Suppose G is a graph given to you. The complement of this graph is denoted with the G dash. Okay, next. अब होता क्या complement में? The vertex set will remain as it is. Complement, when you're doing complement of a graph, the vertex set will remain as it is. The only difference comes in edges. Edges आप कैसे draw करेंगे? The edges will be adjacent if and only if it is not adjacent in G. The edges will be adjacent in G dash. Okay, G dash में ऐसे ही edges आएंगे जो G में नहीं होंगे. ठीक है? Suppose we'll construct a graph here. Suppose this is the example graph. This is your graph G, and we need to construct a G dash graph. ठीक है? यहाँ से हम देखेंगे the edges which are adjacent here should not be adjacent here. ठीक है? Now ये आपका vertex set है. This vertex set will be as it is. Okay, let's check for the U now. Is U adjacent to W here? No. So we are going to include U and W. Okay, done. Now, is U adjacent to X? Yes. So we are not going to include this. Okay. The next. U is adjacent to Y? No. We are going to include this U and Y. Now next. It is adjacent to Z. We are not going to take it. Okay. Is it adjacent to V? No. So we are going to include this. Got how we are doing it? Next. We'll go for the vertex W. Is vertex W incident to U? No. So we are going to draw this, which is already done. Now, is it adjacent to X? No. So we are going to draw here X. Now, is it adjacent to Y? Yes, it is adjacent to Y. We are not going to take this one. Okay, this will not be taken. Now, is it adjacent to Z? No, it is not adjacent to Z. Look here, W and Z are not connected. So we are going to connect W and Z. Now next, W adjacent to V? Yes. So we are not going to take it. Clear? Next, moving on to X. Is X adjacent to U? Yes, it is adjacent. So we are not going to take this. Now, is it adjacent to W? No. So we are going to include it, which is already there. Next comes Y. Is it adjacent here? No. So we are going to include this. Okay? The next, X adjacent to Z? Yes. So we are not going to take it. Is it adjacent to Y? No. There is no connection here. So we are going to form one. Okay? X and Y. Next comes X and U. Acha, done. Now let's see Y. Is Y adjacent to U? No. So we are going to draw one line, which is already there. Okay. Next comes W. There is an adjacency edge here. Adjacent edge here. So we are not going to include this. Okay. For YZ, it is not here. So we are going to place it here. We are going to draw it here. Okay. The next is Y to Z. No edge. So we are going to form an edge. Okay. Next, Y to V. Yes, it is there. So we are not going to include it. Clear? Next comes with the Z. Next, let's go with the Z. Z to U. There is an edge. We are not going to take it. Z to W. Is there any edge? No. We are going to form one, which is already done. Okay. Z to X. Yes, there is an edge. We are not going to take it. Z to Y. There is no edge. We are going to take one. Okay. Z to V. There is no edge. So we are going to take. Okay. Clear? Now let's see for the V. V to U. V to U, done. V to W, we are not going to take it. Okay. V to X. V to X, because it is not adjacent here. Next, V to Y, we are not going to take it because it is adjacent. We are not going to take it. Now V to Z, it isn't there. We are going to take it. Done. So this is your final complement graph. Getting? Okay, so finding the complement of a graph is easy. All you need to do is you need to make sure that the edges which are adjacent in the original graph, it should not be adjacent in the complemented graph. Clear? Now, here is one more example. This is your graph G given, and this is the complement of that graph. Now you check and verify whether it is actually the complement or it is not. Just verify it. Okay? Let's move on to the next one, that is fusion. Fusion bole aap ise merge bole ya identified, one and the same. Okay, so what's going to happen here? The vertices, if suppose you have got two different vertices, V1 and V2, we are going to fuse this vertices. How? By replacing it with a single vertex. Two vertices are said to be fused if and only if they combine and form one single vertex. ठीक है, तो अब edges का क्या हो जाएगा जब हम vertices को fuse कर रहे हैं, तो edges का क्या हो जाएगा? The edges which are incident on either V1, V2 or both will now be incident on the new created vertex. ठीक है, let's understand this with an example. Suppose this is your graph G. Suppose you want to fuse 1 and 4. Suppose if you want to fuse 1 and 4. So what happens? V1, V4 is now fused. It is forming a one single vertex. This is a new vertex now. This is V. We are not going to say this V1, V4. This is V now. Okay. Now, the rest will be as it is. We have got V3. Okay. We have got V2. Fine. Now, let's form the edges. Starting with V1. V1 is incident on V4. There is an edge between V1 and V4. V1 and V4 are on the same edge, so we are going to draw it this way. Okay, getting? No need of direction actually. Next, V1 is incident on V3. So V1 is incident on V3. Clear? Now, V1 is incident on nothing anymore. Okay, let's go for V3 now. V3 is incident on V1, which is done. Okay, V3 is incident on V2. So V3 is incident on V2. Done. Now, V3 is incident on V4. So V3 is incident on V4. Now, V4 is incident on V1, which is already there. V4 is incident on V1, already done. V4 is incident on V3. V4 is incident on V3, already done. This is your V1 fused with V4. Understood? Now in the same manner, if you want to suppose fuse some other vertex, if you want to fuse 1 and 3, or if you want to fuse 3 and 2, same thing will happen. If you want to fuse V3 and V2, so it will be V3, V2 will form one vertex, and the remaining will be as it is. This will be V4, this will be V1. Now V1 is incident on V3. Okay, V1 is incident on V3. V1 is incident on V4. Okay, done. V4 is incident on V3. Okay, done. Okay, V3 is incident on V2. V3 is incident on V2. V3 is incident on V4. V3 is incident on V4. Done? Easy, right? So with this we finished our operations on the graphs. Next we'll see isomorphism, which is very important, and hopefully it may ask you in 7 marks or maybe 10 marks in the exam. So let's discuss that now.